Hello, and welcome to the second session of the breakouts for the Hadoop Summit 2015. Just kind of while everyone's gathering into the room, I just want to see rough show of hands. Who's heard of Tez? Okay, this is just, I've heard about it. Awesome. This is what I expected, a trend over time that showed like this is becoming common knowledge. Okay. Of those people, who's actually running Tez jobs in their company? Another show of hands. This is better than last year. This is better. And that's what this talk is about. It's going to be regarding Tez. So let's just kind of jump right in. People are going to be coming in. I'll try to keep the introduction going just so we can stay focused on time. So I guess I hope you, for those of you that just attended the previous talk, that was perfect. It's a perfect example of why we need this next talk. Maybe we should have reversed the order, but this is kind of nice because we get a history of history. This talk is about history. So this future of Hadoop talk is MapReduce is history, deep integration of Tez with Yarn's timeline server. And my hope is that this talk is going to allow you to help you on your way of your journey into the future technologies of Tez and Yarn and Hadoop. But before we begin, let's just give you a couple of guides to show you where this talk is going to. So each one of us here has a vested interest in data. We wield our data knowledge seeking efficiencies, unlocking value for our customers and ourselves, and aim to make the world better. We seek answers. Through our experience, we've gained knowledge and we've gained the eyes for seeing value in data. And we continue to seek for new sources of data, and we process this data for even more and better answers. In fact, the very act of processing data produces new data sources. And don't get me wrong, I'm not talking about the direct data sources, right? The result of your queries. I'm talking about the indirect data sources, application logs, configurations, metrics, etc. These all form application history that become a new data source, a metadata source, if you will, that has its own value that needs to be unlocked. So that's the data that I'm going to be talking about in this big data talk, the application history data. So the value that we're trying to unlock with application history data is reducing the overall cost of support and the operations of a big data cluster by aiding in the debugging of applications. This history, the application history, allows us to see trends in a single application over time, and they allow us to make comparisons across similar applications. They also allow us to see the health and patterns of the cluster as a whole and across time and space. These self-reflective analytics lower the cost of big data. So history isn't a closed book. And the title of this talk is MapReduce is history. And I don't mean MapReduce is history. I'm not blowing it out of the water. It's not gone. It's MapReduce is history. And what I'm saying is this is a perfect description of one glaring difference between MapReduce applications and applications that were run on Tez. You see, at the inception of Tez, there was no application history, no way to harness the value of the application metadata. So the introduction of a new history server in Yarn 2.5 provided a new way, a new component for Yarn that was generic for history, not just for MapReduce, but for all application types, Tez included. So within the Apache Tez open source community, when this happened, we were compelled to unlock that Tez application history value to our users, and thus a new journey of deeply integrating Tez with Yarn's timeline service began. So at the end of this talk, you'll know the journey that Yahoo and Hortonworks together, along with other Apache Tez community, walked in order to integrate Yarn's timeline service, implemented Tez UI, as well as some of the design considerations and pitfalls of rollout. You'll get to see the fruits of our labor through a fully built Tez UI that's built upon Yarn's new timeline history server. So the birth of our project. Let's actually roll back a year ago. I attended last year's summit, and one of the talks that I attended was presented by Rohini Palaniswamy from Yahoo and Daniel Dye from Hortonworks regarding Pig on Tez. And one of the takeaways for me was the gap for Tez to be production ready for Yahoo. So I'm a Yahoo employee, right? So this is really a vested interest for me. And she mentions 3 fundamental gaps that block this path. Local mode, which is the way to run Tez applications outside of a cluster, development, just kind of some experimentation. Also, speculative execution, which is a way to be resilient to bad nodes in the cluster. And finally, the Tez UI, right? This talk realized the value that that value was missing. So at the time, I'm a Tez developer. I work on the Hadoop team. I am a PMC member in the Apache community for Yarn, and recently became a PMC for some of the work that I've been doing with Tez in the community as well. And at the time of this talk, I was working on implementing the feature of local mode. And so it was either perhaps with great pleasure or perhaps naivety that I asked the community if there was any help that I could give with the community to help write this Tez UI. These are recycling bins, and right, it's a way of throwing something away, or maybe turning it into something new. I like, right? That's the difference here, and this is the danger in volunteerism. In the open source community, if you say, "I'd like to help," you will help, and you have to understand that I work for Yahoo, but I'm not a UI developer, and I can't explain the nuances of competing JavaScript application frameworks. However, I can explain to you how freeing it was that once I created a prototype of this, to throw it away. You see, I had an intern that summer, and Chong Li, as well as I, spent about a month going through the prototyping of rolling out, of integrating with this timeline service component, as well as writing a very rough JavaScript-based Tez UI. It wasn't bad. It kind of was slightly better than the pure JSON version of the history that could be read off the REST API. Tez timeline server is a REST API. Slightly better than that. But it was completely data-centric, and it was lifeless. So in the end, it was thrown away, but it wasn't a waste. It was actually the exact opposite. We had so much knowledge learned from that process. We learned the secrets of integrating it with the timeline history server. We understood that to make something truly great, it has to be designed with purpose. And we understood that it wouldn't take 2 people, 1 developer and 1 intern, to make this project, but it would take a team of developers with diverse skills, all working together. So the first set of unknowns had been uncovered. Now to find a team to walk alongside us for the rest of the journey. So these are the core members of the team. all with their backgrounds described. And I can't say enough, like, this is the team I'm proud to work with, because in the end, I'm not a Tez UI developer, right? I'm not a UI developer. I know backend. My expertise, you can see at the bottom, is I'm a Yarn developer, and I know some Tez, right? I'm kind of at that intersection of Yarn and Tez. It's kind of a good fit for this project, but I can't do Tez UIs. So it was with the extreme humbleness that I was able to work with these guys: Hitesh Shah, Prakash Ramachandran, Ram Venkatesh, Srinath Samarajaparam, and many more. I mean, these are just some of the developers, right? This is the whole community, and these are just the developers, but that's not the end, because we had so many people that gave us feedback, so many trying it out, so many people that we showed this to that gave us and made it better. So how do you build an open source web UI with purpose, especially in the face of a distributed team? The way is to create a living design plan, something that the entire community can get behind and align despite our distances. Over email and video conferences, we spent several weeks hashing out what the mocked up Tez UIs would look like, prototypes, all on paper, so that we could see with our own eyes. And we evaluated together the different navigation options and the page views. And we showed the mock-ups to potential users of the UI and gathered feedback. We used this feedback to iterate, to make the design stronger, more cohesive, and better at answering questions. So when you're designing a page for a website, you have to understand that each page that you design answers a question, and it can't be thrown together. It needs to be kept clear with focus. It has to be intentional. And you need to understand that each question you answer has a cost as well as a value. Specifically, you need to understand the storage and processing constraints required to answer the questions. Some potential views are just too expensive, and others too costly to store the information, and finally, some just too expensive to compute. In order to make sure we're constantly implementing the Tez UI that's the right one, we have to implement these features in value density order and have regular demos. Yes, regular demos, even in the open source community. We would have demos every 2 weeks. So there's some distinct phases in order to roll out the Tez UI. There's 3 components. The backend, which is the timeline history server we talked about, it's a service component that's run in the architecture. It runs along services like the name node and the resource manager. There's also the Tez UI itself. It has to be hosted. It has to be available. And also, you have to enable your applications to write this history and view this history. So where do you install this new timeline history server component? So Yahoo has historically put its MapReduce history server on the resource manager. And while this is a good choice for the MapReduce job history server, it can cause some complications with the timeline history server. It has competing resources. Network, you can easily saturate in this scenario. Disk, you can easily run out of, and RAM, you can easily consume all of. And if you're running it on the same box as the resource manager, you're in a bad state when any of these resources on that box runs out. So a better strategy is to have a separate box. And on this box, if you want to run both the MapReduce history server and the timeline server, that's perfectly fine. This is a better solution. I encourage everyone to roll it out in this way. So the Tez UI can be really rolled out in 2 different distinct ways. Yahoo currently uses the way that's built into the timeline server. It has a plugin technology where you can essentially point the timeline service to a standalone web UI, and it'll host that for you. And that's the method that Yahoo uses. currently. And there's a second method, which is a Node.js-based hosting. We're evaluating that. That might be a better solution. So I think in either of these cases, they both work. But I think the future is likely the Node.js one. So the application enablement. So at Yahoo, turning all the applications on to the timeline history server at the same time would be a folly. Roll them out slowly. A slow trickle is the way to turn this on. If you have distinct user groups, reach out to those groups and say, you know, if you guys can turn this on, we can slowly roll this out, because if it's a flood of information, it can overwhelm the timeline history server. We'll kind of come a little bit about the kind of the constraints that we're up against. Don't forget that this is the future of Tez talk. So let's not forget that some of these are evolving even as we speak. So once you've rolled out the timeline history server and you've hosted your UI and you've enabled applications on your cluster, you finally have your Tez Wine. So what you see is a history server, something that's something that I can be proud of, something that was months of dozens of people's time, and it answers the same questions that the MapReduce history server answers. There's some fascinating technology I love. Like somebody who's really into web UI design, I'd love to really talk to you about some of these questions, because they're just fascinating. Like, how do you implement paging in this scenario? How do you do search? And there's a couple of constraints that kind of are just really fascinating. I won't dive into it, but I just wanted to show it to you. These aren't real jobs. I ran these on my local box last night just to get kind of a flavor of what it looks like. So Tez has a built-in DAG viewer. DAG is a lot like a container. It's like a lot like a job. And so you can see it. And not only just see it, but you can navigate through this. This is one of the critical navigational elements that you can go through. So these are all clickable, and they take you to more details. And finally, the counters. If you were here at the last talk, you heard someone that used counters and metrics to kind of compare the data across time, applications across time, similar applications together. That data is coming from here. This is the real meat of the data. And just for those of you that are kind of curious, this is all developed as an Ember app. So some people may be curious about that. So the question, are we there yet? And it's a mixed answer, right? And I think it's mixed because you have to kind of understand the context of Yahoo and the context of where we are with some of these underlying technologies. So for Hive, we have turned on the integration of Hive and Tez for all Hive applications, and I'd say it's successful in that the UI is actually able to fully use this in such a good way. It's complicated beyond that because there's some other pains of using a new technology like Hive on Tez, like pains of using a new timeline server. So that's kind of the yes and the no. And so Pig, it's a little bit even more difficult. And this is where I'd like to kind of put the caveat there, right? So for Hive, we're able to run easily 5,000 jobs a day over this server. And by estimates, it would actually support roughly 50,000 Hive jobs a day on a single timeline history servers cluster, which for most of you, that's maybe everything, right? That'd be all the ones you could run. However, on Pig, it's a different story. Pig at Yahoo scale is much larger, much more data dense, and we'll talk some of those constraints in a bit. For Pig, I think we could probably only get about 10,000 jobs, and for us, that's only roughly 10% of what we could really have need for. So we hit a bottleneck, and it's not so what you might think. it's not a bottleneck of processing power or even the capability of the web server to handle the web requests. It's not even a RAM issue. It's truly a data store issue. But really, in order to understand that, you have to understand that the amount of history that it would take to store all of Pig's jobs on disk is about 10 terabytes. And when we're talking about big data, that's not much. But when we're talking about a single disk, that's a really big, really expensive disk. So in order to kind of answer this question of like, what is it going to take to roll it out fully at Yahoo, let's get a little bit technical here. So I keep throwing this word out like REST API. So the timeline history service is a REST API. It supports the storing and retrieving of events. The response is JSON, and you put with JSON as well. And those events are collated with a certain type. So and then those types are then further collated into an entity. But what I want to just explain to you, because it's kind of clear, it's not clear what that is, right? Those are fuzzy terms. You all have to understand what a task is. The event is task started, right? There's associated data with that task, right? Like what the time it started was. There's more data associated with that as well. There's other events, task finished. It's an easy event to understand. The type would be task, right? So you have start and finish, and those are all collated into a task. Those, when you roll them up together, is an entity. I wanted to give you that language because some of these details are going to need that language. Security. Setting up that foundation that the timeline history server is a web app, or sorry, it's a REST API, is half the story. It's a REST API, and we've had those in the past in the Apache Hadoop ecosystem. In fact, the MapReduce history server has a REST API, but the ownership of the storage is inverted. So in timeline history server, the source of the data is the REST API. And there is no UI. Developers have to write their own. In fact, that's what Tez did. So this causes a complication because applications have to read and write to the REST API. And browsers, when I go to the UI, has to read and write from the REST API. And that may not seem difficult at first, but if you're running in a secured system, that means that you're using two different security types, and Hadoop doesn't support this natively. So we had to write a wrapper to support both browser, so to kind of translate browser authenticated users into Hadoop authenticated users. And you might be in that same boat as us. So if you care about who's looking at the data in your jobs, you'll need some sort of security solution for that. You may need to write one of these, or at least have one of your customers support you by writing one of these. Perhaps they have an out-of-the-box solution. More complication. So I mentioned before that this Tez UI was written in Ember, right? And that's a JavaScript framework. So the way that JavaScript works is you download JavaScript and then they run within your browser, right? So that your point of all these queries is on your laptop, for example, or on your desktop, and it's reaching out to the server. The timeline server is on another box. So you've created two machines. JavaScript is actually able to handle this fine. You can make your queries from your box all the way across the network, retrieve those results, but browsers are very picky about this. They know that there's such thing as a cross-browser, cross-origin security hack, and it wants to prevent you from doing this. So you have to only do that for sites that you enable this for. So we've implemented a certain security filter that's going to handle this. But if you have the Tez UI installed, you need this filter enabled. It won't work without it. All right. So we've taken you kind of deep. And I think we'll go one level deep, well, not too much deep, because I don't want to lose you, but there's there's some pieces of information that if you're writing applications or application types, or perhaps your Hadoop application wants to integrate directly with the timeline server outside of maybe the history, but you want to keep your own metrics, or there's something else you want to keep track of. That can be done, but you have to understand what it's about and how it works and some of the constraints. So when you, small keys are key, is what I've got here. And what I mean by that is the REST API has a backing store. It's underneath the hood, right? It's storing the data, the events that are coming in from your history. It's storing that history into a store. And the way it does that is it takes these history events and it stores them in the database, but it's a key value database. It's like a dictionary, right? That you look up something and it has an associated value there. Each piece of information associated with that event is arranged sequentially, right? So it's like an object store. So if you were to go into the database, you'd say, oh, here's my start event for my task. Here's the start time. Here's the end event. Here's the end time. Here's all the metrics that are associated with that. They'd be all co-located in the database. And each one of those is a record in the database. Each record has an index into the record. Right? How do you look that up? What's the words that you can look that up in the dictionary? And the word is based on the type and the ID, and also there's a timestamp that's in there as well. You don't have control over the timestamp. So I say it's key because if you're like Yahoo and there's 30 million tasks a day, each with a task attempt, that's 60 million events. Each one of those stores records in the database. And in fact, each one of those stores 20 records in the database. So now we've gone from 60 million to 1.2 billion records, right? And that's actually well within the constraints of the underlying key value store. But you have to understand then is that 1 byte in the key translates to 1 billion is 1 gigabyte in your storage requirement. So small is better. 95% of the data that was stored in the database for Tez was counters, was these metrics, the essential value that we're trying to unlock. So consider possibly compressing these. And I don't necessarily mean, gzipping. That's one possibility. But also consider not writing all of them. Half of the values in Tez are zero-based counters. It's like, how many errors do you have? 0. How many write failures do you have? Error. How many write errors do you have? 0. There's not much value to those. What you really want to know is when there's something wrong. Store what's wrong. And also consider, for storage purposes, creating a dictionary of terms. Store into the timeline service perhaps a dictionary of your terms so that you can keep things small. There's a couple of other details that are here. I'm just going to list them here for people to go back through and reference this material. There's one equation I want you to be left with that's going to help you sleep better at night. And that's effectively, for people that are rolling this out, what's my capacity model for memory? And in this case, the web server is going to run fine with 4 gigabytes of memory. It's going to need about 8 gigabytes of, that's Java memories for the web server. And it's going to need about 8 gigabytes for this off-heap store that's going to keep track of all the LevelDB database, the kind of the underlying database store. So the future. So I said there's this limitation, right? One disk. Yahoo has a need for 10 terabytes on that disk. That's not going to work, right? So we need something in the future. And Apache has been well aware of this. In fact, they're working on version 2 of the timeline history server. Version 2 is a scalable store. And that's what we need here. Going forward to roll this fully out at Yahoo, there needs to be a scalable solution that's reliable, right? Is highly available, so that when it goes down, you don't lose history. You don't lose the value that we've been talking about here. So I guess my takeaway is this. If you're thinking about Tez and you want to run the Tez UI, these are going to be rolled out really soon in all the Hadoop distributions. Play with it early so that when this version 2 comes out, you won't be taken by surprise and you'll have the expertise to keep moving forwards. So with that, can I have any questions? There's 2 mics up at the front. Please just kind of look across the aisle to see who's coming here for that. So help yourself. Thank you again for the talk.
Question. I noticed the UI for the Tez that you showed up there looked very similar to the Ambari Tez slider. Do they share similar code bases?
So yeah, Ambari actually uses the Tez UI itself. It embeds that natively into the. So if you're an Ambari user and you're like, I don't know what this is, I think there's a plugin that supports natively pulling in the exact Tez UI into one of their views, I think is the right word. Yeah, absolutely. So if you're an Ambari user, expect that you'll see this coming up very soon. Good question. All right, if there's no other questions, enjoy. I think lunch is up next. Thank you again.